This is Sean Young, and I'm here to talk to you about moderation and mediation for Module 2. So we're going to start off with moderation. Moderation can be best explained as a third variable impacting the nature of the relationship between two variables. So this could be anything from changing direction to changing strength drastically to going from like a severely shallow slope to a severely steep slope, something along those lines. Just to introduce the data that I'm going to be working with, I just made a continuous variable of random numbers, then I made a categorical variable of zeros and ones, an interaction, which is the multiplication between the two, and an outcome that encompassed all three of those variables, and some random noise. I turned that into a data frame, and then I made it into an outside data set so that I could make graphs, because I will admit I could not get the plots in R to work, but I could make them work in SPSS. So simply, moderation, you want to have your how the interaction between your two outcomes or your two predictors impacts your outcomes. So for that, I had to make sure that I centered all my variables first, as to not have to worry about multi-collinearity. And then after that, I had the interaction between the two variables as predicting y. So centered x1 and centered x2 were about significant predictors of centered y, as well as the centered interaction between x1 and x2 predicted y in the end. So to better understand this, I plotted it. So as you can see, at 0 in x2, y is very shallow. But at 1 in x2, x1 predicts y at a very steep angle. So we can see that the nature of the relationship changes based off of the level of x2. The nature of the relationship between x1 and y changes based off of the relationship, or based off of the level of x2. So then, like any regression, we need to worry about diagnostics. So I used all four of the diagnostic charts. Everything seems to be fine. No worries about heteroscedasticity. No worries about normality. Then we can move on to mediation. So mediation is more of a temporal pathway. So you think that there's a relationship between x and y, but there's a mechanism in the middle that gets you from x to the mechanism to y. So it's a temporal pathway in which your predictor and outcome are explained through the process of a mediator. In order to make my mediator variables, or my mediation variables, I had my x, my y, and my mediator. My x was just a bunch of random numbers. My mediator encompassed my x, and then my y encompassed my mediator, and therefore encompassed my x. And so then the best visualization I can give you is that there's probably a direct relationship between x and y, and then there's probably an indirect relationship. Well, if we're hypothesizing mediation, there's an indirect relationship from x to the mediator to y. There is the ability to have both a direct and indirect relationship. There's also the idea of full mediation, in which the direct relationship between x and y will be fully explained by the mediator. So starting first with you want to start first with the direct relationship between x and y. And here we can see that x is a significant predictor of y without the inclusion of the mediator. Then you want to understand the relationship between x and the mediator. And as you can see here, x is a significant predictor of our mediator variable. Then we want to know if the mediator and x simultaneously are doing a good job of predicting y. Here we can see that the x becomes non-significant when including the mediator in the model, but the mediator is still a significant predictor of y. So then, just from here, we would be able to suggest some sort of mediation, because all of the pieces work together in the ways that we would regularly assume and would stop at saying that there is some sort of indirect relationship between X, the mediator, and Y. However, I went ahead and did the Sobel test and created numerators and denominators based off of the coefficients and standard errors of the coefficients. And so the outcome of the Sobel test was a 1.16. And then when you put that in and got a p-value, the Sobel test basically is creating a z-score and then use that z-score to find a p. So we have the z-score of 1.16. That p is greater than 0.05, so we cannot deduce that the pathways are mediated, that the mediator was a sufficient mediator as compared to 0 from X to Y. Finally, we did a lot of different regressions, so we had a lot of different diagnostics. Again, looking at the QQ plots, looking at the fitted values and residuals, looking at Cook's distance and leverage. We weren't worried about outliers, we weren't worried about normality, and we weren't worried about heteroscedasticity. So thank you so much. I hope that you have a great evening. Goodbye.